Circles, the third lesson. We're going to do tangents of circles. So I hope when you hear that, the first thing that comes to your mind is you're thinking the word tangent. Isn't that a trigonometry word? It is actually, but we're going to refer to a line that's called a tangent line. So let's see what all this looks like. Let's read our I can statements. Okay, please write all three of these down. I'll quickly talk through them while you're writing. You want to be able to identify if a line is a tangent line. There's a real easy way to do that. You'll see in the pictures. You want to be able to solve for any missing segment lengths given a tangent line. There's a typical picture again that will always show up. And you'll solve for perimeter of a polygon that has an inscribed circle. That means it has a circle inside of it. Once again, the pictures will clue you into everything. These pictures will be things you'd like to add to your cheat sheet at the end of the video. In your vocabulary section, please take the time to draw these pictures and listen to what we say about them and add to them. A tangent line is any line that touches the circle in exactly one point. So it can intersect the circle, touch it in only one point. This is a point of tangency, this is, and this is. Tangent lines are also perpendicular to the radius segment that touches at that same point. Don't make that harder than it is. We're simply saying if you draw in a radius at any tangent line, it'll always be a right angle. So there's not one drawn in on this second picture, but let's say we wanted to draw in the radius from O to B, then you could automatically, if you know it's a tangent, put that right angle mark in there. So that right angle we're going to use a lot because it'll form right triangles. And then look at the second picture here and read the information. It says this is something that is always true. If you take any outside point, it'd be called like an external point, point A sitting out here. Anytime you take any point at all outside of a circle, if you draw in the two lines that would touch that circle only once, they would be tangent lines. It'll always make this picture. I call it the ice cream cone picture. And on an ice cream cone, those two tangent lines that form the ice cream cone are always congruent to each other, always equal. Okay, so that's really the two pieces of information we need. Let's see how it applies in a picture. Example 1 says determine if line AB is a tangent line to the circle. That word if means if you can prove it is definitely tangent, then you're good. You're going to say it's a tangent line. Well, what would prove that it's a tangent? It would be this information right here. Is that really a right angle? If you have a way you could prove that to me, then you can say AB is a tangent line. Well, let's look just at the picture. Forget the circle for a minute and look at just the picture of the triangle. On that triangle, it is a right triangle, so you could say, I'm going to check out the Pythagorean theorem. If I can set it up where I take the two legs coming out of the right angle, 4.2 and 5.6, if I can set that up and prove that it really does equal whatever 7 squared is, then if that's true, I'll say yes, it's definitely a tangent because that was definitely a right angle. So quickly doing the math here, these are some funky decimal numbers. Use a calculator, make sure you get the same thing. You're asking yourself if the left side will end up equaling the right side. When you add those together, that's a 17 right there, by the way, 0.64. Add those together, you do get 49. Is that true? Yes, it is. So you'd say yes, it's definitely a tangent line. Again, what we're basing that on is the fact that tangent lines always form a right angle where they touch the circle with the radius. And we have the picture that shows a radius and a possible tangent line. We prove that it's definitely a right angle by saying this right here. And that means it's definitely a tangent line. Let's do the same thing in number 2. Pause it. Set up your Pythagorean theorem, pause it, and see if you get the same thing I get. Here's my Pythagorean theorem work. Again, I'm setting that up based on the fact of I'm checking to see if this will make a right angle. And to finish off my work, when I add those two together, I get 55.13. Does that equal 46.24? I'm not even going to write that again. No, those are not the same, so it is not a tangent line. And again, we're basing, is it tangent or not, on the fact that, does this truly give us a right angle right there? So if it fits the Pythagorean theorem, it would. If it doesn't, we say no, not a tangent line. Pictures for example 2. Now let's still apply that whole right angle deal. Let's read the directions and see what's going on and see what we can find out. It says find the segment length. Assume that lines that look tangent are tangent. So if they say that, then that means, okay, so this segment right here looks to be a tangent line. So since they said we can assume it is, let's put in a right angle. Let's go ahead and do the same thing on number 4. This looks to be a tangent line running that direction, so let's put in a right angle. Remember, the tangent line is on the outside of the circle. So this 9.7 down here, that segment, that's not a tangent line. Part of it goes through. So if we're assuming it's a tangent line, let's do anything we can, circles or triangles, to figure out the missing number. And I would totally focus just on that triangle. We know this time that it is a right angle, so we have a 6, 8, and they want to know this length. You can set up the Pythagorean theorem, 6 squared plus 8 squared equals x squared. Or better yet, if you memorize some of those special right triangles, you don't even have to do the math. That is a 6, 8, 10 triangle, which is a multiple of a 3, 4, 5. X should be 10 units. Let's look at number 2. Or excuse me, number 4. Again, let's focus just on that right triangle. And on that right triangle, we would set up 6.5 squared plus the length we don't know, x squared, equals 9.7 squared. Again, we can set up the Pythagorean theorem because it's definitely a right angle there. And by the way, notice, just because in some pictures it's different, this 9.7, I know it's that whole length because they ran those arrows from end to end like that. If you do the math here, I'm going to quickly do mine. You should come out with x is 7.2. I'm not even going to show all my math. Make sure you square this number, and you would actually subtract them before you square root. And just out of curiosity, I thought I would ask you if that whole length for x is 7.2, what if someone asked us for a radius length of that circle? You just found a diameter so you could half it. Things like that could come up too. All right, example 3. Here's the ice cream cone picture, and if you're not recognizing that, it's like 4 ice cream cones or 3 ice cream cones on number 6, all the way around the picture. Now, if you'll look back at your vocabulary, we said that when it's an ice cream cone picture, that's any 2 tangent lines coming from the same point, then those line segments are congruent. And so all you do here is simply work your way around the picture. The most you're going to do is some adding and subtracting. So a good place to start would be right here in these 2 spots. On this ice cream cone, all by itself, if that's a 9, then this segment right here is also a 9. Sorry, I'm having to write big there. So there's one ice cream cone. Here's another ice cream cone. If this is a 5, that's a 5. Because remember, 2 tangent lines are always congruent, tangent segments are always congruent to each other. Now from there, you have to start working your way around the picture and doing some adding and subtracting. You need to go to the left side towards that 9 because there's nothing you can do over here on the 5 side. If the whole entire side length is 12.4 and you don't know that the red segment of it is 9, all you got to do is some subtraction and you will find the rest of that one line segment. So this little tiny segment right here is 3.4. Then ice cream cone your way around. If this is 3.4, this is 3.4. Then you can do some subtraction again on this whole side. 11.7 minus 3.4. Take 8.3, put it right there. That's the rest of that 11.7 segment. And then ice cream cone your way around. If there's an 8.3 on this side, then this is an 8.3. Now, it actually says find the perimeter, so we do need to add up all of these side lengths. You can do 8.3, 8.3, 5, 5, 9, 9, etc. Or you could do the total side lengths if you wanted to add those up first. I usually pick up a calculator and just add every number I have. So to finish the problem, add 9, 9, 5, 5, 8.3, 8.3, 3.4, 3.4. if I did my math right, please feel free to correct me if I'm wrong in class tomorrow, the total for the perimeter is 51.4, because perimeter does mean add your way around. Let's look at number 6. Do all of your ice cream cones and then add your way around. Here's an ice cream cone, the 7.1 one. Here's one in 6s. That's a 6, that's a 6, and then you need to start subtracting. On this side, go 15.1 minus 7.1. You'll get an 8, which gives you another 8, and that means we're done actually. Add 8, 8, 6, 6, 7.1, 7.1. I've got for a perimeter 42.2 units. And finally, example 4. This one asks us to solve for x. So yes, the algebra ones sometimes are a little harder. It's just applying everything you know already and doing the algebra to find x. Assume that the lines which look tangent are tangent. So that means here's a tangent segment. Here's another tangent segment. If you wanted to put in the right angle marks, you certainly could, because here's a radius, so that makes a right angle. Here's another radius, that makes a right angle. Now there's a lot of lines going on there, but basically all you really need, even though it looks worse than that, is, hey, tangent segments are congruent to each other. Set that up, equal to each other, and solve for x. When I work through the algebra, I have x equals 6. You can double check that by plugging in a 6, either in your head or on paper. 4 times 6 is 24 plus 6 is 30. So the blue segment is 30. And 6 times 6, 36 minus 6 is also 30. Double check that you got the same thing. Okay guys, this circle stuff goes really quickly. As you've figured it out, we do a new topic every day. It keeps building on each other, but yet you have to practice that particular topic. You cannot stay a day behind. So please show up in the mornings or after school if you need some extra help, or find a friend who knows what's going on. We will have a quiz next time. This time I really mean it. Last time we were just fooling you. And so remember, you can have your cheat sheet. You could have chords, angles, arcs, and tangent line information on all of your cheat sheet circles. Good luck.